Hello everyone, I am AMMAJI DUPPADA, and today in this session we are going to see method 11, non-exact equation, but a special case it is. Actually, the theory behind method 11 and method 12 that are upcoming, that I have already explained in the previous video. You can go through that, but a little recap I will give you about method 11, so that we will see the next directly example problem. So method 11 in this non-exact equation means actually the form is, that very simple. It is like m is function of x comma y dx plus n is function of x comma y dy is equal to 0 is the equation which is non-exact. This is non-exact. So in this case, what actually the condition should be satisfied is, one condition should be satisfied in this. The condition is dou m over dou y minus dou n over dou x over n should be a function in terms of x only. Should be a function in terms of x only. In that case, your non-exact equation can be converted into exact equation. Exact differential equation. How? You have to multiply with an integrating factor. Multiply with the integrating factor. So what is that integration factor? That integration factor is, you got something right here, function in terms of x only. So you multiply with that e power integration of f of x dx. It means f of x, integration of f of x you can calculate. E power integration of f of x you can calculate. That is called integration factor. If you multiply with this integration factor, your non-exact equation will be converted into exact differential equation. If once the equation is converted into exact differential equation, you know how to solve it. A direct solution is available. Direct solution is available. You know the formula in the previous videos. You can see this is what actually method 11, a special case like. So method 12 is also almost similar. You can, by this time you can understand by seeing that theory behind method 11 and method 12 video. So okay, now we will see the example. So this is the question. So it is looking like m dx plus n dy is equal to 0. You know what is m, what is n. So let me write m is x y squared minus e to the power 1 over x cubed. So I want to calculate. It is dou m over dou y. With respect to y, you are doing, it is partial differentiation. So x is constant. So x in the first term, x is constant, y square differentiation is 2y. So you are getting 2xy. Second term, with respect to y, if you do x is constant, so whole term is constant. So answer is 0. Same manner, you calculate n, what is n? Minus x squared y. Please think that actually, see, don't forget this minus here. M dx plus m dy form it is. So plus minus will come actually. If you write only x square y, that minus sign will be, you are simply avoided, like, by mistake. So don't leave minus simply. So n, you got it. So dou n over dou x, you can calculate. Y constant because you are doing with respect to x. So minus x square, differentiation is 2x. So finally, you are getting like minus 2xy. It means from this, you can say dou m over dou y is not equal to dou n over dou x. It means your given equation is non-exact. Your given equation is, you have given an equation called non-exact. So, but one more thing you can try. The case is like, now the case I will check, like, I don't know whether it is really under which case it will come, like dou m over dou y, I calculate this, minus dou n over dou x over n I will calculate. Dou my over dou y, how much? 2xy. Minus dou n over dou x minus 2xy. So minus into minus plus. So it is plus 2xy. Over n how much? Minus x squared y. 2xy plus 2xy, 4xy over minus x squared y. Y term will be cancelled, x1 term will be cancelled. So finally you are getting like minus 4 over x. See, this is function of x only. This is function of x only. It means my condition is satisfied. Method 11 condition is satisfied. So my integration factor is now integrating factor is e to the power integration of f of x dx. So e to the power integration of f of x, how much here? Minus 4 over x dx. That is equal to e to the power minus 4. If you take out 1 over x, different integration is log x. So e to the power minus 4, I can take x to the power. So e to the power log x to the power minus 4. So here also base e power log base e. Both will be cancelled. Exponential term and logarithmic term will be cancelled. So finally you will get x to the power minus 4. Nothing but 1 over x to the power 4. Now this is called integrating factor you got. So with this integrating factor, if you multiply the given equation, your non-exact differential equation become exact differential equation. So now we will multiply with this. Just let me go to the next page. So my integration factor is, I got integration factor is 1 over x to the power 4. So now my given equation, now I have to multiply the given equation. Same again, I am writing the whole equation. X y square minus e to the power 1 over x cube into dx minus x squared y dy. This is the given question only. So not much difficult. So you multiply with this integration factor. So what I'm doing is I'm multiplying x to the xy squared minus e to the power 1 over x cube over x to the power 4. Because 1 over x to the power 4 you are multiplying with dx minus x squared y over x to the power of 4 is equal to, sorry, mdx plus ndy is equal to 0. So this is the equation like. So now what we have to do, you have to simplify this one. You have to simplify this one. Xy square over x to the power of 4. It means y square over x cube. One x term will be cancelled. Minus e to the power 1 over x cube over x to the power 4 into dx minus x square y x power 4. So one x square term will be cancelled. Y over x square will remain. Dy is equal to 0. Now I am saying that it is exact, but you can confirm it if you want. Actually, non-exact equation is converted into exact by multiplying with this integrating factor. By multiplying with the integrating factor. So now, if you want, you can check it. You can treat this one as m1. You can treat this one as n1. So you calculate dou m1 over dou y. If you calculate dou m1 over dou y with respect to y, if you do one first term, 1 over x cube is constant, y square term is 2y. y square term is 2y. So it means 2y over x cube you are getting like. So dou n over dou x you calculate. Dou n over dou x. So minus y is constant. 1 over x square. It means x to the power of minus 2. It means minus 2 into x to the power of minus 2 minus 1. It means minus 2 into x to the power of minus 3. It means minus 2 over x cube. Minus 2 over x cube. It means finally you are getting 2y over x cube only. It means this both are equal. Dou m1 over dou y is equal to dou n over dou x. It means it is exact. I'm just verifying it. Every time you no need to verify if the the condition is satisfied like. So now I understand that my equation is exact. So this is my equation, right? Let me say equation 1. So my first equation is exact. So now I can apply a direct solution. I can apply a direct solution. So let me write this equation once again. Y square over x cube. This I have to write once again. Copy. Okay, now that exact equation once again I am writing so that it will be easy to write solution. So that equation is 1 implies. So the same equation what I have left there, first equation I'm writing once again. Y square over x cube minus e to the power 1 over x cube over x to the power 4 into dx minus y over x square dy is equal to 0. This is exact only. We have verified also. This is exact differential equation. Now, what is the solution? We know that actually the solution of the given differential equation is, you can write every line. Solution is this is m if you treat this one, if you treat as let us say m2, this one you treat as n2 because already mn we have used, m1 n1 also we have used. So m2 n2 I am taking. So integration of m formula is integration of m2 dx. Y should be constant plus integration of n2 dy. N2 is free from x terms. N2 is free from x terms. So is equal to some constant, one arbitrary constant. So integration over m2 dx. M2 means what? Y square over x cube minus e to the power 1 over x cube over x to the power 4 dx plus integration of n2 dy. N2 means minus y over x square dy is equal to constant. So now if you solve this one, this integration thing, you will get a solution. So now first term I am writing integration with respect to dx. Y should be treated as constant. Y should be treated as constant. And n2 should be free from x terms. If n2 is free from x terms, this term will be 0. Actually, this term you no need to write. Why? Because n2 is free from x terms. It means this total term become 0. You can write. So it means this total term become 0. So you can neglect it. So in this first term, y square over x cube with respect to dx, y square is constant. So I am taking y square out. 1 over x cube, it means x to the power of minus 3. It means x to the power of minus 4 over minus 4. right? So second term minus integration over e to the power 1 over x cube. This what I do is x to the power 4, which is there in the denominator, I am taking to the top, dx is equal to, this term anyhow 0, so is equal to constant. So first term is okay, simple. What about second term? Here we have to apply an ancillary or auxiliary solutions, or what you call the formulae or whatever the concepts we know, that you have to apply to solve this one. It looks simple, actually it is simple, but the thing is you should know how to write that by using another variable. Like, so again I am writing the same equation. Now what I do is the same equation I will write here. So this equation, final equation, like y square into, it means minus 1 by 4 y square into x to the power minus 4. This equation is minus e to the power minus integration of e to the power 1 over x cube into x to the power minus 4 dx. Dx is equal to constant. So to solve this term, especially to solve this term, what I do is I use another variable. If I take 1 over x cube as t, 1 over x cube as t, what actually it will become? X to the power minus 3, nothing but 1 over x cube only, it is t. So now what you do, both sides you differentiate. Both sides you differentiate. What will happen? Minus 3, x to the power minus 3 minus 1 dx is equal to dt. See, minus 3, x to the power minus 3 minus 1 means x to the power minus 4 only. Dx is equal to dt. It means x to the power minus 4 into dx is equal to minus 1 over 3 into dt. See, now the problem is looking simple. First time I am writing again, minus 1 over 4 y square x to the power minus 4 minus integration of e to the power 1 over x cube. You treat it as t. X to the power minus 4 into dx. What you are getting? Minus 1 by 3 into dt. Minus 1 over 3 into dt is equal to constant. So same term I am writing once again. Minus 1 over 4 y square x to the power minus 4 minus, see, this minus into minus plus, 1 by 3 is constant I am taking out, e power t dt, e power t only is equal to constant. See, what actually we have done here is, I don't have any direct formula to solve this one. I have no direct formula to solve this one. So I applied, like, change of variables method, like it is. I just changed x variable into t variable so that I can solve that problem. But remember, now your solution, this is actually final solution only, but it is having x, y, and t terms also. I told you, when the question is given in x and y terms, your answer also should be in x and y terms. So finally, the final equation should be minus 1 over 4 y square x to the power minus 4 plus 1 over 3 e power t means what? Actually, what you have treated t? 1 over x cube, right? E to the power 1 over x cube is equal to c. That's it. As simple as that. The solution is over. So this is final solution of the given differential equation. It means the equation which satisfies the given differential equation. That is what we call a solution. This is a special case. As I said, we dealt this one under method 11. So I will show you from the beginning once again. So just a quick review I just give you. So in the first page, we have seen non-exact equation, a special case. We know what is the method 11, a special case, like this condition should be satisfied. This condition should be satisfied. And it should be a non-exact differential equation. If the two conditions are done, then integration factor is e power integration of f of x. You have to calculate this. With that integrating factor, you have to multiply the whole given non-exact differential equation so that your non-exact equation will be converted into exact differential equation. Once it is converted, you can apply a direct solution. That is what actually we have done. We have taken an example. So in this page, what we have done, we checked m, n, dou m over dou y, dou n over dou x, non-exact. And we have taken this case, satisfied function of x only. So integration factor I have calculated. That I got 1 over x to the power 4. I multiplied with the whole equation with 1 over x to the power 4 in this page. After multiplying the given equation, I got this equation called 1. That is exact. I verified also. So once the equation is exact, we know the direct solution. So that direct solution I have applied in this page. But in this, what actually one term I got little difficult. What it is, like e to the power 1 over x cube into x to the power minus 4. To solve that particular term by using integration or integrator I want to apply on that term. To do that, I changed variables because direct formula is not available. So I changed the variables, x variable into t variable. But at the end, my answer should have only x terms only. So finally, I have replaced the t term in terms of x terms. That's what I have considered or I have assumed. That's it. Thank you all for watching this video.